Hello everyone. In last lecture I had given you a problem. You might have gone through that video. That is video number 1, basic properties of charge. And in that problem we were given some amount of sample like 127 gram of copper sample, and each atom is losing one electron, single electron, and we were asked to find out the total charge on the sample. So let's try to understand how to solve such kind of problem. First of all, we are supposed to get the number of moles present in the sample. So number of moles can be written as by using the formula given mass divided by molar mass. The given mass is 127 and the molar mass is 63.5. That is also given in the problem, and we get number of moles as 2. Now we can write the total number of atoms using Avogadro's number. So therefore total number of atoms present, I can say that this number is simply 2 into Na, that is Avogadro number, where 2 is the number of moles. So we have 2 into 6.02 into 10 raised power 23, which is Avogadro number, and this is like 12.04 into 10 raised power 23 atoms. Fine, fantastic. Now as each atom is losing one electron, so we can say that total number of electrons lost by the sample, total number of electrons lost by the sample would be exactly equal to the number of atoms present, which is this. So I can say that total number of electrons lost by the sample is this number of electrons, right? Now we know how much charge an electron, a single electron carries. So we can easily find out the total charge carried by these number of electrons. Therefore total amount of charge on sample can be written as 12.04 into 10 raised power 23 multiplied by 1.6 into 10 raised power minus 19 coulomb. Here one must not forget that the sample is losing electrons, so means losing negative charge, so the sample must be achieving positive charge. All right, so this is the final answer to this problem, and this is how we are supposed to deal with it. All right, let's proceed ahead. Now after this let me introduce very important thing about the methods of getting a body charged, right? We are having a body and we need to give some charge to it. I am going to explain how we can give some charge to a body, right? This is generally is not as directly, but it is seen that somehow it is framed with some another concept, with some another problem. So this knowledge is, I think, must for everyone going through this chapter, and as I have committed that I'll be covering each and every single topic of the of the 12th standard, and in each topic we'll be talking about illustrations also, and so in order to get the latest videos instantly, you are suggested to subscribe the channel first of all. So without any further delay, let's start talking about this thing, methods of getting a body charged. See, here we have basically 3 methods. Let me introduce all these 3 one by one. The first one is by friction, right, or we can say by rubbing. Fantastic. And the second one is by conduction, all right, and the third one is by induction. Okay, I'm going to explain all these three one by one, right? Each and every single detail will be disclosed over here, right? So let's start talking about this first case by friction or by rubbing. All right. See, when we talk about the case of friction, we need to rub one body against another body. Let's say I am having two bodies A and B, and let's say these two bodies are rubbed against each other. So basically what happens, this rubbing produces heat energy, right? And due to the heat energy, when absorbed by the electrons, let's say over body A, these electrons, suppose getting that heat energy produced as a result of friction, rubbing, these electrons when get absorb heat energy, these electrons find themselves free from the atom, and these electrons are transferred from one body to another body like this. So the body which is going to lose electrons get positively charged, and another body which is going to get electrons gets negatively charged, right? The point we must remember in this context is that the magnitude of charge which one body gets is exactly same as that on another body. Moreover, the sign of the two charges are opposite, right? So here we can say one more thing, that the body which loses electrons will get mass decreased. Its mass decreases because electron possesses its mass, that is 9.1 into 10 to the power minus 19 coulomb, and this body, because it is losing electrons, so that means it is losing its mass also. So we can say that this body mass of this body will be decreasing, whereas mass of another body which is receiving electrons will be increased, right? So here let's make a note in this context that we are talking right now, that is the case of friction or rubbing. So here one can say that the two bodies, get equal and oppositively charged. All right. So I think this is very simple thing now, right? Because we have discussed this thing, the bodies, how bodies are going to get equal and oppositively charged. Second thing I must say, the body which gets positively charged shows decrease in its mass, whereas mass of another body increases, right? This is again very simple thing, because we have discussed this, like in what way, how electrons are transferred from one body to another body, and resulting into the change in mass, because electrons possess their own mass, right? Fantastic. Now let's talk about the second case, which is slightly more important than the previous one, that is by conduction. So let us introduce this conduction thing. What do we mean by conduction? See, as it is clear by its name, conduction, here we are supposed to consider only this conduction in case of conductors. We must be having bodies, conductors, right? Bodies are to be taken as conductors only. We are not supposed to select, in this case, insulators, right? So let's say here we are having two bodies. One is having some charge, let's say Q1, another may be electrically neutral, or it may also be charged. Let's say this is carrying some charge plus q2. All right. Now suppose we are going to bring these two bodies closer to each other, right? We are going to make contact in between these two bodies. Whether you can directly make the contact between two bodies, or you can take help of a conducting wire like this. This is the switch. Let me allow to close the switch like this. All right. So what happens next? Let's check this out. See, because here bodies we have taken our conductors, so conductors we know allow flow of charge through them, right? So electrons are free to move from one conductor to another conductor, but it would not be according to their wish. It would be totally dependent on the value of potential, electric potential. Yes, you are hearing me right, electric potential. But potential we have not covered so far, right? We have not talked about potential for now. So we cannot use potential concept in this context. That is the limitation. So what should we do now? We for due to that restriction, we are supposed to consider bodies as identical, right? So I am going to consider here identical bodies. Okay. Fine, these two bodies I am considering identical, and when bodies are identical, it can be easily understood that if the bodies are identical, the total charge will divide itself equally amongst the bodies, right? Suppose initial total charge, when I say total charge, that means the charge on both the bodies, QA plus QB, and let's say this is Q. And let me tell you about the final situation in case of identical conducting bodies. These bodies are conductors, moreover these bodies are identical. So identical conducting bodies we are having, and the final charge on each body in this case would be Q by 2, right? Because charge is going to divide itself equally, right? This is very simple thing. You can make your common sense over here that as the bodies are identical, so charge must be equal eventually over the bodies, right? So this is all about conduction. In conduction we make somehow contact between the bodies, and the total charge is divided equally on both the bodies in case of identical bodies, right? So this is the case of conduction. Now let me introduce the third case, that is induction. All right. Now here also we are supposed to consider conducting bodies which we want to get charged. Suppose, let's say we are having, let me explain this. Suppose we are having one body A which is already charged, and another body is suppose electrically neutral, body B, but this is conductor. This is only and only for conductor that we are discussing. You might be thinking about the case of insulators. That will be covered in next chapter. Don't worry about that. We are because this is the beginning, we are too basic for now, so our discussion is limited only up to conductors, right? So this is a conductor and this is electrically neutral. We know the behavior of conductor very well, that conductor consists same amount of conductors allow the flow of charge through them, and here we have equal amount of negative charge and equal amount of positive charge, because this is electrically neutral. So what will happen, as this conductor is placed nearby this charged body A, so here the negative charge, that is electron or lying inside this conductor, must get attracted, and these electrons will get accumulated at the nearest side, right, due to the force of attraction offered by this plus q charge, right. At the same time, due to this accumulation of negative charge at one side, will be getting net accumulation of positive charge at another side due to the deficiency of negative charge at the farther side. All right, still you can see that this body is electrically neutral, because same amount of negative and positive charges, both the charges are of same amount right now, and in order to get the net charge on body, we just connect this body with the earth, that is the, we call it as earthing. So we have done now earthing also. Now as a result of earthing, let me tell you the concept, actual concept of earthing. What does it mean? It means again the potential, whichever surface is earth, all the time the potential of that surface becomes zero, right? We are talking about conductors. All right, so the potential over the surface of this conductor has become zero now. But again, same thing, but we have not covered potential yet, so we cannot talk about potential much. For now we can understand the phenomena going on very logically, like this plus q charge is attracting this negative charge, so this negative charge is bound with this positive charge, and this positive charge accumulated the farthest side is being repelled by this positive charge over body A, so this will flow into the earth. Let me tell you the basic concept of this. Actually positive charge does not flow, does not go from any place to any other place, rather electrons are coming up. Electrons must be coming up, because these are the electrons only which are allowed to travel, which we find free, right. So electrons are free, electrons travel easily from one place to another place. So here what must be going on, electrons from the earth must be coming over this body, and this positive charge due to these electrons, flowing electrons, coming electrons from the earth, must be getting neutralized. So what will happen after some time, when you see this positive charge, whole positive charge will flow into the earth, and then we remove the earthing, and then we remove body A also. So we will see that some negative charge, net negative charge, will be appearing on body B. Hence this body B is electrically charged, right. The point which is to be remembered in this case, that if it is a case of conductor, we get equal and opposite charge on body B, right. If you want to know more about the reason why the body is getting same charge, same magnitude charge, negative is obvious, right, due to force of attraction. But if you want to know about the reason behind this same magnitude, you will have to stay connected with this channel, because in next lectures, upcoming lectures, will be covering about this concept with its reason. All right, so for now let's end the video at this. In this video we have covered the method of getting a body charged, and we have three methods: by friction, by conduction, and by induction. All right, next video is going to be very, very important, because next video will be covering Coulomb's law basically, and we'll be taking illustrations also related to Coulomb's law. Okay, and if you want to if you want me to give illustrations related to these events also, then please do comment, and don't forget to subscribe the channel. Thanks for watching.